G'day guys, how you going? My name's Ben Hardless. Welcome back to the ENM2600 playlist. Today, before we get into some of the more complicated and hairy stuff, I wanted, by special request, to do a bit of a revision sesh on completing the square, because I know that a lot of folks have difficulty with it, and so I thought I'd do a quick rehash, a bit of a mad minute, which will probably take 10 to 15 minutes on completing the square. Complete the square sounds kind of cultish, a bit like find your destiny, complete the square. But really it's just a bunch of maths. So, sorry, here we go. So this method of completing the square is useful for solving quadratic equations of the form ax squared plus bx plus c equals 0. Right now, over in the corner here, I do have an example one with some actual numbers, and we'll do that a bit later. But first, let's have a look at this general form, right? So, in this case, where I'm saying a, right, this a here would be a 1 there, right? This b is going to be this minus 10, right? Even though it says plus b, that b can be a negative number, in which it is in this case up here in the top right. So the minus 10 is the b, and the c is really all of this stuff here. If we just moved, if we just put it all on this side and made this side and made the right hand side equal to 0. So what we would do is we would, without solving it right now, we'd plus 16 to both sides, minus 25 from both sides, so that would go, and you'd have plus 16 on the left. But we're not doing that just yet, so I just wanted to show you what we're actually talking about here. Let's get on with doing this. So you might have seen something called the quadratic formula that you kind of taught to memorize to solve these types of equations. But what we can do is we can do something like this. If we try and get there in the general form, well, an interesting thing to do might just be to factor out an a. So if we do that, now if you actually multiply this out, you'll see a times x squared will give you ax squared, a times bx on a, well, the a's would cancel out and you get bx, so that matches what's up here. If you do a multiplied by c on a, the a's will cancel out and you'll just get c. So it is indeed the same as what is on the top line here. Now what we can do is this. 1 on a times all of this on the left equals 0 times 1 on a. Well, 0 times anything is 0, right? So this on the right hand side is just going to remain 0. This on the left hand side is the a's are going to cancel out, and you're just going to get 1 times all of this stuff in the brackets. So we can really just get rid of all of the stuff outside the brackets. Now we're left with this, and we don't really need the brackets because there's only stuff inside the brackets left. So now we've got this. This is interesting. And I could have equally said, we could, from the top line, we divide all terms by a, but I think we get to the same place, and hopefully this makes sense to you so far. So the first step is to make anything that is separate to an x term over on the right hand side of the equation. So on the second line here, we had x squared plus b on a x plus c on a equals 0. The only thing not attached to an x term is the c on a, so we're going to move that over to this side. And the following line is how we've done that. So we've subtracted c on a from both sides, and hopefully you see the plus c on a minus c on a cancels out, and so we will be left with something like this. Now, if you're following so far, you're doing pretty well. Let's get to the next step, step 2. So the next step is to halve the coefficient of x and take note of what it is. So we're just taking a note, right? Alright, so what is the coefficient of x? So that's b on a. Now half of that, so if we times that by a half, really that is the same thing as b on 2a, right? So this right here is what we're after. So we've taken note of this. Next step is to square that value that we just got and noted down and add it to both sides. So what would b on 2a squared look like? Well, b on 2a squared is equal to b squared on 2 squared, which is 4, times a squared, right? We're just squaring all the terms. Cool, b squared on 4a squared. This is us doing it, so x squared plus b on ax plus b squared on 4a squared equals b squared on 4a squared. So we've added it to the right hand side as well, minus c on a. Okay, so where is all of this going? Well, if you're familiar with the quadratic formula, some of this might start to look like it's taking shape to you. And if it doesn't, don't worry, because you'll get there in the end. Alright, the next step. Step 4 is to make a perfect square. And you might be wondering, well, how on earth am I going to do that? You know, I've got this thing here, and I want to make a perfect square. Ooh. Well, noting our half the coefficient of x that we took down before, once we've got it in this form here, what we can then do is make a perfect square. And that's going to look something like x plus this thing that I've circled in yellow, b on 2a squared. And that is going to be equal to everything that was on the right hand side in step 3, b squared on 4a squared minus c on a. We could try and simplify this right hand side a bit, right? By trying to figure out what to do about these two things, combining them together. So, you know, to combine the fractions together, they need to have the same denominator, don't they? So we can do a bit of multiplication here, and what I mean by that is, if I multiply this c on a term over here by 4a on 4a, is that alright? Can I do that? Well, what is 4a on 4a? Well, anything over itself is just 1, so we're really just multiplying the fraction by 1, and that's totally fine. So if we do that, what we get is b squared on 4a squared minus 4ac divided by 4, and 4a times a is just 4a squared. So what we're then left with is x plus b on 2a squared is equal to, and now because these terms are over the same denominator, what we can do is we can just do this. We can join them together over the same denominator, right? Whew, that was pretty cool. So b squared minus 4ac divided by 4a squared. Now, what can we do here? We can take the square root of both sides, and so this is interesting because well, this square root and the squared are going to cancel each other out. So that's pretty interesting. We're gonna get rid of those, and then we don't need the brackets anymore because there's nothing outside the brackets. And this square root is going to have two possible results, right? There could be a positive and there could be a negative result. So if we subtract b on 2a from both sides, what we get is step 5, which is the derived quadratic equation. So this is starting to look pretty familiar. So if we subtract b on 2a from both sides, we're going to get rid of that, and we're going to subtract b on 2a from this side, and then we're just going to switch these around, right? So what we'll do now is we will have, that is x is equal to negative b on 2a plus or minus square root of b squared minus 4ac divided by 4a squared. Now this b squared minus 4ac over 4a squared, the square root of the whole thing is the same as taking the square root of the top and the square root of the bottom, and this fraction line is still there. Anyway, if we take the square root of the bottom, can we do that? Well, of course we can. It's what's the square root of 4? Well, that's 2. And what's the square root of a squared? Well, that's a. So this bottom term here can be simplified to 2a. Now this negative b is over 2a, and this square root area bit here is, this square root bit here is over 2a. So can't we just put them together? X is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And that, my dear friends, is quadratic equation. And the good news is this equation will work for any quadratic equation. So you know, if you have an equation like this that we were looking at before as an example that we haven't solved yet, you can just plug that into this, and it'll work just fine. So you can solve it from this, or you know, this one doesn't have an a term. Well, it's a 1, so it's not really that tricky. But if you did, you know, the best thing to do is probably to just plug it into here. And that's the benefit of using a general, finding a general solution sometimes, because it works for multiple situations. The case specific is sometimes a bit easier to follow with actual numbers plugged in, but that doesn't always tell you how to solve other equations of a similar type. So here's a good example of where the general form is very useful to us. But if we wanted to just solve this without applying the quadratic formula, I shall show you how I would do it if I was not allowed to remember the quadratic formula. Well, what I would do is I would remember the steps. I would simplify this, because the 25's on both, plus 25 on both sides, so I would subtract 25 from both sides and get rid of that straight away. Now, and make anything, step 1, make anything separate to the x on the right hand side. Well, we've got that, so we've got step 1, x squared minus 10x equals negative 16. Alright, cool, that's step 1. Halve the x coefficient and take note. Note, half of negative 10 is going to be negative 5, right? Step 3, square that value and add it to both sides. So negative 5 squared is going to be 25, right? Positive 25. So we're going to add it to both sides. So let's do that. X squared minus 10x plus 25 equals negative 16 plus 25. Then the next step is make a perfect square, right? So, oh well, how do we do that? All we do is we just take the x term and we can say, well, what was the value that we had over here in step 2, and we just take that and use it in our square, and then we have the perfect square. And if you multiply it out, right, so you would get this right here. is equal to, and this 25 minus 16, minus 16 plus 25, same as 25 minus 16, so that is going to be 9. So we've simplified that to 9, and then we take the square root of both sides, right? So we're going to get x minus 5 is equal to root 9 plus or minus, don't forget the plus or minus, and then x is equal to, well, we're going to add 5 to both sides, so this is going to be 5 plus or minus root 9, which is 3. So x is equal to 5 plus 3 is 8, and x is equal to 5 minus 3, which is 2. So those are the two possible solutions. And you know, all I've done is this completing the square thing. So just to rehash, step 1, I've moved everything that is not attached to an x over to the right hand side, and that's what you can see here. The next thing I've done is I've halved the coefficient of x and taken note of it, and in this case it was -5. The next step was to square that value I'd just taken note of and add it to both sides. So I did that. So I've added, you know, -5 squared was 25. I added it to both sides, and what that allowed me to do was create a perfect square. And it always works. You can always use this method to create a perfect square, and then you simply can take the square root of both sides, do a little bit of transposition, and you can solve for x. Anyway, I appreciate that this example was a fairly simplistic one. You probably didn't need to use this method to go about solving this. If you were half savvy, you probably realized pretty quickly that you could simplify this and solve it by factoring. However, this is just to demonstrate that the method works. If you had an a term here, if you had something up here, the coefficient for the x squared term, then what you would do with that is you would divide all of the terms by a to get rid of the coefficient on the x squared term. Okay, but really, when in doubt, just try to remember this guy if you've got an exam or something, because deriving it is a bit of a headache. But anyway, if you were curious about how do you actually get there, this was how you get there. Anyway, I hope this was useful to you, and I hope you enjoyed it as much as I did, and I look forward to seeing you in the next video. Thanks for your time.